All right, so here's the solution to the challenge. So the first thing that we need to do is we need to import some frameworks, and we're going to be using CoreML as well as Vision,
Apple's machine learning framework.
and the next thing we're going to do is to create a method called detect that takes a single parameter called image. And this is going to be in the format of a CI image, so a core image, if you remember. So in order to pass our user picked image into this method, we're going to have to convert our user picked image. So let's create something called CI image,
And use it to store the results of our CI image overload that turns a UI image into a CI image.
and as you can see, Xcode is very unhappy with this because at the moment, if you have a look at this user picked image, its data type is of optional any. So we have to convert that into the data type that is expected in this method, which is a UI image. When we try to display this image inside the image view, we downcasted it into a UI image. So we can actually do this at a higher level by moving this up here. So we're saying that let the user picked image be of data type UI image. And we can wrap this whole thing inside an if-let just to be ultra safe. All right, so now we're saying if the user did indeed pick an image and it can be converted into a UI image, then we're going to call it user picked image, and then we're going to convert it into a CI image. Now I'm going to use a guard statement to protect the CI image. So guard let this statement to try and convert our UI image into a CI image. But if it fails, then I'm going to throw a fatal error, and the message is going to say cannot convert to CI image, so that we'll know what's going on. But if it did succeed, then we should be able to call this method detect, passing in this newly created CI image. So let's do that. And just check to make sure that your casing is the same as this one. Alternatively, you could just call it something like converted CI image. And that will make it a little bit more explicit when you're selecting it here. All right, cool. So we've let the user pick an image, we've converted it into a CI image, and then we are passing it into this method called detect. So at this stage, our image is right here, and we're going to do some funky stuff with it in order to detect what is the flower that's in the image. So the first thing that we need to do is to use VN Core ML model to create a vision container for our ML model. So what is our model called? So let's have a look at this class, and you can see it's called flower classifier, and it has this variable called model, and that's what we're going to tap into, and we're going to create a vision container for it. So let model equal VN Core ML model for model, which is called flower classifier dot model. And this, of course, is something that can throw an error. So let's mark it with a try and use a guard statement to protect the cases where it might fail. In which case we'll throw a fatal error and we'll say cannot import model. So we've created a vision container for our model. The next thing we need to do is to create a request. So we'll call it request, and it's going to be done using VN Core ML request. And it is going to take a model, which is our newly created model up there. And it's also going to have a completion handler. So we're going to call the request that comes back request, and the error we're going to call error. And we're just going to delete that code placeholder for now. Okay, so we've got our model, we've got our request. We just need to create the handler to process that request. So let's call that handler, and we're going to use VN image request handler to create it. And it's simply going to take a CI image as the input, which is, of course, this image that got passed into the method. So it's just called image. All right, and then we're going to say handler dot perform request, and the request is in the format of a array of VN Core ML requests, and it is going to equal this request that we created up here. So this line of code can also throw an error. So let's mark it with a try and enclose it in a do catch block. so that we can actually log the error if there was one. All right. Final step is once this request has completed, then our completion handler is going to activate and we're going to get back a request or an error if there was a problem. So we're going to do something with that request, namely we're going to process it and look for what that image was classified as. So I'm going to call it classification and I'm going to set it to equal the request.results.first. And this is going to be cast as a VN classification observation. Now the classification has a property called identifier, and this is a string that describes what the classification was. So if it was a flower, it might be rose or it might be Barberton daisy or whatever it may be. But this is what we want to put at the top of our navigation controller. So let's tap into our navigation bar. So self.navigation item.title, and that is going to be set to equal the classification identifier. So let's put that over here. And that's all the code that we need to write in order to use our flower classifier model to detect what flower might be shown on the image that the user took. So let's give it a spin. All right, so here's our app. I'm going to tap the camera button and I'm going to take a photo of our flower and I'm going to hit use photo. Now it's going to process that image and give us the result. So it's telling us that this is a Barberton daisy. And although I have to say my knowledge of flowers is pretty limited, so this app is really useful for me, but I've Googled what Barberton daisy looks like and I think this is the right one. So there's a couple of UI things that are a little bit niggling. Firstly, why does our image look so odd on screen? Well, remember that we allowed the user to edit the image and that cropped it into a square crop, so a 1:1 scale factor image. Now our screen is actually a rectangle. So in order for this to look a little bit more decent, you can change the image view's content mode to aspect fit or aspect fill, whichever you prefer. And the other thing that is kind of odd is that why is it the Barberton daisy classification is all in lowercase? Ideally, I would want it to say capital B and capital D for Barberton daisy, especially when it's displayed on the nav bar. So the reason is because if you have a look in our flower labels, all of these are actually all lowercase. But we have a neat trick in Swift that we can change that. So here, where we're setting the navigation title to the classification.identifier string, we can add another dot and we can say capitalized, and it turns it into a capitalized representation of the string. And now, if you run the app again, you can see that it looks much better. All right, so looks a little bit nicer, and also you can see that the result is now capitalized, which looks a lot nicer. All right, awesome. So we've now managed to make our app use our custom image classification model that was converted from an open source cafe model, and we're able to start classifying all the flowers that are around us. So if you haven't coded along, give it a spin and check out this awesome app. But in the next lesson, we're going to make this app even more awesome because we're going to cross-match the result that we got back from our image classification against Wikipedia to bring up a description and a useful snippet of information about the flower, as well as an image of the flower on Wikipedia. So you've got all of that to look forward to, and I will see you on the next lesson.